Hi teacher, my name is Warin Jittakajornkiat and my nickname is Nest. Today I will present you about nanofiber air filter. This is an air filter with nanofiber technology. This is a high efficiency air filter with unique nanotechnology features. It is made of nanofiber with diameter of less than 100 nanometer. These filter nanofiber are mainly constructed of carbon nanotubes, well known for their strength, flexibility, and good conducting qualities. It is in the industrial sector, energy and environment. Firstly is clear contaminant, renewable energy system, and carbon capture and storage or CSCS. This is a sample of the application that can be in the energy and environment sector. Next one is the property of nanofiber air filter. Nanofiber filter improve in indoor air quality by trapping microscopic dust, bacteria, virus, and allergens. They save HVAC energy due to decreased airflow resistance. Carbon nanotube make them long-lasting. This filter resists high heat and chemical, making them suited for dark situations. And this is the application of air filter with nanofiber technology. First one is home and building air filtration, automotive industry, healthcare and life science, industrial processes, aerospace, personal protective equipment, and last one is air purifiers. We can use the air filter in like other application that not have in the slide because it is uh, very good product. And we can also use it in the machine in the factory or in the air conditioner at your home. And the nanofiber are 1D nanostructure. The main material to use to make the nanofiber air filter is mostly carbon nanotubes, and the dimension design of nanofiber air filter vary depending on their application. Like a HVAC filter can be several square feet, whereas phase mask filter are significantly smaller. And about the structure, nanofiber arrangement share filter a dense porous network forms and passes through this substance which trap microscopic particle. Nanofiber are under 100 nanometer. And next one we will talk about the advanced nanofabrication. First one we have to substrate preparation. Mostly we will use the silicon wafer, screen and prepare for the next step. And the next one is catalyst deposition. This step we will catalyst a catalyst layer, typical a thin layer of metal such as iron, nickel, and cobalt. It's based on the substrate. In this fabrication, we will use nickel. And the next one is carbon nanotube growth step. Carbon nanotubes are generated on the substrate using a process known as plasma enhanced chemical vapor deposition or PECVD. PECVD employs plasma to lower the reaction temperature, allowing for more controlled growth of carbon nanotube. And the next one we'll talk about FIB milling. This is the top-down processes. From the image, we can see at the symbol A, we will see the sample design including platinum gate, silicon oxide insulating layer, embedded nickel catalyst, and ITO adhesion layers. Next one, you can see the preparatory FIB milling at B. Yet you can see the hole inside that we will do a FIB milling, and the C we will get the carbon nanotube at the middle and in the hole. This is the result of carbon nanotube synthesis. And the next one, you can see the three image. The first one is nanofiber and carbon nanotube fabricated within microgate cell by FIB milling for hole with approximately 1 micrometer while mill through the catalyst layer. In the picture 2, mill beyond the catalyst and allow 1 micrometer in the diameter and 300 nanometer wide and as deep as the nickel layer. And you can see from the picture B and C and D, this is the sample of image of carbon nanotube that we get from this nano fabrication. As you can see from the figure 3, this is a SEM image of the carbon nanotube that we get. And after we do a FIB milling, they can be put into a polymer solution and electrospun to produce composite nanofibers with embedded carbon nanotube. The carbon nanofibers can be created after a second carbonization phase. This is step electrospinning. Before electrospinning nanofiber, a polymer solution with the necessary component is created. This solution is placed into the syringe and slowly inject. Solution holding needle is connected to the ground collector with high voltage. The needle chip shoot liquid due to electrical force. The solvent evaporates as this jet moves in the air, leaving solid nanofiber on the ground collector to form a non-woven mat. Adjusting electrospinning parameter like solution characteristics, apply voltage, needle collector, distance, and feed weight can regulate this fiber diameter and shape. From the picture, you can see the figure 2. This is a diagram showcasing of electrospinning mechanism. And you can see the from the figure 4 is the overview of several air filtration mechanism on cross section. And you can see from the on the left under you can see the process of how we get the clean air after we use the filter. Like we have a filter medium that block off contaminants. And from the figure 7, this is the image of the machine that used to do electrospinning. And the last step, we have the product that to clean to remove any contaminant from manufacturing. And next, we have estimate pricing and investment and benefit. If we can use outsourced component, so we can neglect the machine. So we will calculate only the production cost. That we have a cost of raw material, energy, equipment depreciation, and labor. So the cost per piece is around $50. And after I calculated that and I want to sell per piece is around $100. The profit that I will get it around 50% profit per piece. So this is okay for me to buy this product. And this is all the reference that I used in this presentation. Thank you very much ครับ